Hello everyone, this is Tiger again. So today we will be talking about the second half of the paper from 2019. Are you all ready? So let's take a look at the first question we have, which is question 16. I would say this question is just a number theory question. And the main focus of it is that you need to understand what are prime numbers and what are triangular numbers, what are square numbers. So it's about the definition. So it would be hard for me to put it into any category, let's say prime numbers, because I don't think there is any other specific questions that involves the definition of triangular numbers. So I think it has just shown up once in all the papers, or twice tops. So first of all, a triangular number is just either like 1, 3, 6, 10, or so on. And it can be obtained by just adding 1, 2, 3, 4, and all the consecutive numbers. So whenever you stop at any number, the sum you get is always going to be a triangular number, okay? And it says that she is using the digits 3, 4, 5, 6, 7, and 8, once each. So first of all, I would say that the easiest one to start with must be the square numbers, because we are all very familiar with them. So we can see that there are just two numbers I can make with these digits, either 36 or 64. And both of them are using a 6. So it means that next I'm looking at the prime numbers, which doesn't have a 6 in it. So for any prime numbers that are 2-digit, it can only end with 3 or 7 in the list. Of course, it can also end with 1 or 9, but they are not in the list. So we have 43, we have 53, we have 83, and then we have 37, we have 47, we have 67, but then it needs a 6. We need a 6 for the squares, right? So I don't write the 67 over there. So after writing these down, next I'm moving on to the triangular numbers. So we can definitely just ignore all the triangular numbers that are smaller than 20, no, smaller than 30, because we don't have the digit 2, right? And we don't have the digit 1. So the first triangular number that is greater than 30 is 36, which is 1 added up to 8. And it has a 6 in it, so we abandon it. The next one is 45, and then there's 55, which is 1 adding up to 10. So, well, we don't have 2 5s, so we can cross it out as well. And then adding 11, we have 66, so of course we can cancel that too. And then adding 12, we have 78. Adding 13, we have 91. But then there's no 9 and there's no 1. So it means that for the triangular numbers, it could only be 45 or 78. And for square numbers, it could only be 36 or 64. So I just need to try the different possibilities out. Yeah? So let's say starting from 36 being the square number. And if I'm using 45 as the triangular number, it means that I have 7 and 8 left, but 87 is not a prime. So the first case doesn't work. If I'm using 36 and 78, then I have already used the 3 and 7, which means the prime number will not have any numbers to end with, any digits to end with, right? So it means that the square number cannot be 36. So now we know that the square number is 64. And it means that the triangular number can't be 45, it must be 78, because 4 is also appearing in 45, right? So the two remaining numbers are 3 and 5, which means that the prime number is going to be 53, okay? So that's how we can solve question 16. It requires a little bit of knowledge to these terminologies, and it also requires a little bit of logic to solve this problem. And question 17. So I would say that this is an easier one. It's a word problem on ratio. And of course, it also includes the knowledge in geometry, which is like area and perimeters. So that's also included in this question. It says that a rectangle is 3 times as long as it is high. I'm not really sure why is it describing it that way, but I guess we do understand what it means. It is 3x long and x wide, right? So it means that the area is going to be equal to 3x squared, where the perimeter is 2 times x adding 3x, which is 8x. Yeah? As for the square, the area is 12 times the area of the rectangle. So it means that a square is 3x squared times 12, which is 36x squared. So what is the side length of the square? The side length of the square is, or let's say L. The length of the square is going to be root 36x squared. That's going to be 6x. Yeah? And finally, what is the perimeter of it? The perimeter of the square is 4 times 6x, which is 24x. Oh. That's equal to 24x. Which means that the ratio of the perimeter of the square to the perimeter of the rectangle is 24x to 8x. So if you divide 8x from both sides, that's equal to 3 to 1. 24 to 8 equals 3 to 1. So the answer is D for this one. Okay. So once you understand what this question is talking about, you should be able to find the answer. Of course, you can also try to use, for example, if you're not using x, you can use 1 and 3 for the rectangle, and that would also work for you. So you can use some exact numbers to put in that as a trick of it. And then question number 18. So it's another number theory question. And I would say this one is kind of easier. It's on cube numbers. It is asking you what fraction of the integers from 1 to 8,000 inclusive are cubes. So first of all, let's think about what is the largest cube within 8,000. We know that the smallest cube is going to be 1 cubed, right? Which is what? And what is the largest cube within 8,000? So the number 8,000 itself looks pretty suspicious because it's actually 20 cubed. 20 times 20 times 20 is 8,000. So it means that from 1 to 8,000, I have 1 cubed to 20 cubed, which is 20 numbers altogether, or 20 cube numbers altogether. And as a fraction, it's just going to be 20 over 8,000 numbers, which is equal to 1 over 400 if you divide both the numerator and the denominator by 20. So the answer is going to be C. Okay? As for question 19, this is a Sudoku question. So it belongs to the miscellany module, and it's on Sudoku. Well, so if you have done any Sudoku before, I would say that this question might be manageable for you. So it literally says that each row, each column, and each 2x3 rectangle must contain all the numbers 1 to 6 once each. So that's the rules of the Sudoku. You might see that this is a little bit different because it only contains a 6x6 square instead of a 9x9 square, like the regular Sudoku we might have been used to. But how we do it is the same. First of all, we need to find x, right? So we're just taking a look at the row, column, and a box of x, and we can see that there's not much useful information we can do there. So let's just try to work on where we can find the most information. So you can see that in this box we have 2 and 4, and it is including the column of x that goes through this box, right? So we have 2 and 4 there, we have 6 and 3 there, we also have 1 there. So 1, 2, 3, 4, 6, it means that this box has to be 5, right? Because we can't put any other numbers if we want 1 to 6 ones each in each column, row, and rectangle. Now, knowing this, we can just follow this same column to see if we can find any more clues there. So if you go to the bottom, you can see that there's a 2, there's a 1, 3, 5, 6, which means that this bottom box must be a 4. And finally, we can see that there's a 2 in this rectangle, together with the 3, 4, 5, 6 already in the column, which means that this box is going to be 1. So the remaining one, x, must be the last one remaining in the column, that is 2. So that's how we can solve this question, by looking at the column of x. The next one is going to be another number theory question on prime numbers. And I would say that this question is also pretty easy, because it says that Emily is writing down the largest 2-digit prime such that each of its digits is prime. So how many digit primes do we have? Or how many prime digits do we have? We can only use 2, 3, 5, or 7, right? These are the only 4 1-digit prime numbers. So if you want to make the largest one, of course, we want to start with a 7, right? And 75, 72, these are definitely composite numbers. So the only possibility is 73, which is a prime number. And if you want to write down the smallest 2-digit prime, of course, I want the tens place to be as small as possible. So let's say we're starting with a 2, and we can see 23 is going to be the smallest 2-digit prime. So if you're doing the subtraction of the two numbers, what is the answer that you're getting? 73 take away 23 equals 50. So the answer is E, 50. All right, I guess this is not too hard. The next one, 21, is a geometry question on angles, say interior and exterior angles. Okay, so first of all, we can see that there is a rectangle, there is a regular hexagon, there is a square, and there is an equilateral triangle. So what are the interior angles of these 3 shapes? Well, if you know the formula, 180 times n take away 2, being the interior angle sum of any polygon, where n is the number of sides, then you divide it by n to find each angle, right? So if you know that formula, you can calculate the angles, or if you can memorize those angles, they should be 120 degrees, 90 degrees, and 60 degrees respectively, right? So hopefully you know that. And we're trying to find the angle XVR there. So this is the angle that we're looking for. Now we know that this angle is 60 degrees, being an interior angle of an equilateral triangle. And this is a right angle, being the interior angle of a square. So if I want to find the angle XVR, there's only one angle that I actually need to calculate on, which is the angle QVR. And how do I find angle QVR? We can see that very curiously. We're joining V and R there. Well, definitely, because we need to find the angle XVR, right? But apart from the angles, what other properties do regular polygons have? they also have the same side lengths, right? So you can see that each equilateral triangle has the same length as each square, as the square, and that's the same length as the hexagons, right? So it means that the triangle QVR is isosceles. It's not iOS, it's isosceles. And wow, how do we find the top angle of QVR? The top angle VQR would be equal to an interior angle of a hexagon, take away the interior angle of the square. So that's 30 degrees. And as for the base angle QVR, we know that's equal to the other angle, right? So QVR is equal to QRV because they are both the base angles of isosceles triangles, so they should be the same. So angle QVR is going to be 180 degrees, which is the interior angle sum of triangles. Take away the top angle 30 degrees, and then you divide it by 2. So you get 75 degrees for angle QVR. And now we can find XVR. So the angle XVR is going to be 360 degrees, which is the sum of all angles at a point. Take away the 60 coming from the triangle, the 90 coming from the square, and the 75 that we have just calculated. And the answer is going to be 135 degrees. So the answer is D for this one. All right. And for question 22, wow. So if you have ever read about some, like numbers with special properties, you might be able to get the answer from this one, like for this question at the first glance, if you can memorize it. But if not, it's okay. It's completely fine. There's definitely a very smart way we can analyze this multiplication puzzle. So it belongs to the miscellany module, and it's a multiplication puzzle. Okay. So first of all, we can see that a 4-digit number is multiplying 9, and then all the digits are swapped around, right? So the first question is, if a 4-digit number is multiplying 9, how can it still be a 4-digit number? If I need that to happen, it means that t has to be 1. If t is any bigger than 1, it means that it will no longer be a 4-digit number as the product, right? Because 2 times 9 is already having a carryover. So it means that t is 1 and p is 9. And of course, this p is 9, this t is 1. Also, we know that there shouldn't be any carryovers from the hundreds place, right? So what multiplying 9 won't have a carryover? Well, you might say 1, yes, definitely, but we have already used the 1, and we know that they're all different digits. So the only possibility left is 0. So that's how we can find the value of r. And if you want to investigate one step further to solve the whole puzzle, that would be easy as well. 9 times 9 is 81 with a carryover of 8, right? And 9 times a adding 8 ends with a 0. So it means that 9 times a must end with a 2. What times 9 ends with a 2? 8, right? 8 times 9 is 72. So we know that a is 8. And 72 adding 8 is 80 with a carryover of 8. 9 times 0 is 0. Adding 8, that's 8. So 1089 times 9 is 9801. That's how we can find the answer to this question. Okay? And the question 23. So I would say that this is definitely a geometry question. And I would say this is about cutting and filling. So I would say it's about completing the shape. we can see that the length of JK is 6 centimeters and the length of PQ is 4 centimeters, right? Where K is the midpoint of RS, which means that this is 2 and this is 2. So this has to be 4, such that 2 and 4 adds up to 6, right? And we also know that this is 6 and this is 4. So how do we calculate the shaded region? Well, definitely it is now an irregular shape, right? So is there any way I can make it a regular shape? I can just try to make it a right-angled triangle, such that this is also 4 and this is also 4, right? That's a square, the parts that I have filled in. So now I just need to remove this empty square from the whole triangle to find the area. So the area of the triangle is 8, this side, having a side length 8, times this side, 6 adding 4, that's 10, divided by 2, removing 4 times 4, which is the area of the square. So that's going to be 40 take away 16, which is 24. Once you know how to solve this question, once you know how to make it into regular shapes, then of course you can solve it immediately. Okay, does it make sense to you? All right. And the next one. So this one is a little bit hard, but just a little bit. I would say this is definitely a geometry question on angles, but it is also relating to algebra because we are expressing everything in letters, right? So it is like using letters to represent unknowns. So we can also say that it is related to algebra. Depending on which part of it you're not able to do. Is it the algebra part or is it the angles part? So, first of all, we are looking at P, Q, R, S, and T. P is the interior angle of a heptagon, right? Regular heptagon, which means all of them are going to be the same. Q is going to be the exterior angle of a heptagon, as well as T. T is also an exterior angle of the heptagon. And what about R and S? You can see that R and S should be the same because both of them are in an isosceles triangle using an interior angle. Oh, so you can say that's P, using an interior angle as the top angle. So they are the base angles of the isosceles triangles, right? So it means that R should be equal to S. And also we know that P, which is the interior angle of the triangle, adding R, should be 180 degrees because the interior angle sum of any triangle is going to be 180 degrees. So what does it mean? It means that P adding R adding S is 180 degrees. What about Q and T then? They are the exterior angles, but they are the same, right? So Q adding T is equal to 2Q. Altogether, all of them adding together would be 180 adding 2Q. And it's done. All right, that's how we can find the answer to this question. And the last one. So I might just need to hide myself for now. The last one is just a number array question. So it belongs to miscellany and it's about the number arrays. We have 15 numbers there, and I want to rearrange them such that 5 integers along each edge. have the same sum. And we want to know what is the greatest possible sum. So, how do we get the sum? Basically, we are adding every 5 numbers there, right? So it means that I am actually counting each of these numbers at the corners twice. So if I want the greatest possible sum, of course, I want these corner numbers to be as big as possible, right? And also we can discover that there are 3 numbers in the center that are not counted at all. So I want these 3 numbers to be as small as possible. Yeah? As for the sum, we can see that all the other numbers are calculated once, right? So we can simply list an equation. First of all, we are just trying to add all the numbers in the list. 1 adding all the way up to 15. But we also know that I don't want the smallest numbers. So definitely I'm putting the smallest numbers 1, 2, and 3 into the middle, such that they are not counted, right? So I am removing them from the 3 sums. And now, the 3 numbers at the corners are each counted twice. And what are those numbers? I want them to be as big as possible. So I'm adding 13, 14, and 15. And then finally, that's the total of 3 sums, right? So I need to divide it by 3. So the calculation will just be 1 adding all the way to 15, that's 120. Taking away 1, 2, 3, that is taking away 6. Adding 13, 14, 15, that is adding 42. And then divided by 3, so we have 156 divided by 3, which is 52. And that is going to be the answer for this last question. All right. So that's essentially everything for the second half of the paper. If you have any questions, please feel free to let me know. If not, then I will see you next week, everyone. Bye-bye.